All right, Algebra 2. Here we are with day 2 of 6.2, inverses, and today we're looking at inverse graphs. We're going to find the inverse, we're going to graph the original, and we're going to graph the inverse and see what's up. All right, so our original of f of x equals negative 2x plus 5. Let's find that inverse. Step 1. We go with y equals negative 2x plus 5. Remember this from yesterday? Step 2, we're going to switch to x and the y. Step 3, we're going to solve for y. Get this y by itself now. So we're going to subtract 5. And divide everything by negative 2. And this one is a little bit of a tough one to start with. Okay, so I'm going to rewrite it like this. Y equals x minus 5 over negative 2. That's kind of tough to think about how to graph that. So here's what I'm going to do. Okay, x minus 5 over 2, we're going to split that up into two fractions. X over negative 2 and a minus 5 over negative 2. X over negative 2 would be negative x over positive 2. It's going to be the same thing. Negative 5 over negative 2 is going to be a plus 5 halves. Okay, so not necessarily prettier, but probably a little bit easier to graph. Okay, back to the top. F of x. Negative 2x plus 5. Okay, this is like pre-algebra, algebra 1 type stuff, so hopefully this is no sweat. It's already in slope-intercept form. We're going to start at positive 5 on the y-axis. 1, 2, 3, 4, 5. Our slope is negative 2. Down 2 over 1. Down 2 over 1. Down 2 over 1. Maybe even go backwards, go up 2, backwards 1. Get your straight edge out. Let's graph this line. Okay, there it is. And we'll do the best we can with this one. It's not perfect. Okay, probably not the best problem to lead off with. It's not perfect, but it should work out okay. 5 over 2 is going to be 2.5, 2.5, 1, 2.5, do the best we can. Our slope is negative 1/2. So I'm kind of thinking, let's go down 1/2 over 1 to get on a nice point. And now we can do our normal negative 1/2 is down 1 over 2. Okay, you can look at it as one number, negative 1/2, so down 1/2 over 1, or down 1 over 2. I'm going to guess, though, that most of us probably would just naturally go with down 1 over 2 right away. And we'll be stuck in the halves the whole time. And that's okay. We should be able to make this work. Go up 1, backwards 2 even. And we'll do our best to connect this one. Okay, what do you see? What do you see there? What's so special about these inverses? Okay, you might not be able to see it quite as clearly. I think it's pretty close. It's easier to see when the lines are balanced. They're the same length. It's easier to see it. But if you look at this, these should be reflected over the line y equals x. Just y equals 1x. Okay, so this piece of the black line should reflect over and be this piece of the red line. And this piece of the red line would reflect down and be that piece of the black line. Okay, think about our inverse points yesterday. Right, when we were doing inverse points, we had like 2, 1 flips to 1, 2. So if I have on the black line, if I have 1, 2, 3, 4, 5, if I have 0, 5, what should I have on the red line? 5, comma 0. 1, 2, 3, 4. Look at it. There it is. 5, comma 0. It worked. Right? What's another nice one? On the red line, we have 0, comma, well, 2.5. So do we have 2.5, comma 0? Yep, that would flip down to there. Okay, pretty cool. All right, let's have you hit pause and try the next one on your own. Can you find the inverse? Can you graph them both? And does it look like they reflect over? Can we find some nice reflection points? Let's see if you can do that. Go ahead and push pause and try that on your own. All right, welcome back. Let's see how we did. Okay, remember we're going to switch this to y equals, and now we're going to trade spots with x and y. X equals y over 2 minus 3. We're going to add the 3 over. X plus 3 equals y over 2. Then we're going to times by 2. 2x plus 6, this is a nicer one, isn't it? Equals y. Definitely a lot nicer than the other one. Okay, so our original half x, x over 2, minus 3. So we're going to start at minus 3. 1, 2, 3. Our slope is 1/2 x. So up 1 over 2. Up 1 over 2. Up 1 over 2. Maybe go down 1, backwards 2, a couple. And let's graph this line. Okay. And then our inverse, we have 2x plus 6. 1, 2, 3, 4, 5, 6. And our slope is 2. So up 2 over 1, up 2 over 1. Don't have a lot of space going that way, so let's reverse it. Let's go down 2, backwards 1, down 2, backwards 1, down 2, backwards 1. Okay. And we'll connect these points. We'll graph this line. And we should see that it's tough if you didn't do very much. If you just had like this little bit and like a lot over here, it's not going to look like it's going to reflect very well. But the more we do of each line, the more it looks like it's going to reflect nicely. Otherwise, if you just do a little piece of one and then the whole thing of the other, your mind might play some tricks on you. Yep, and we can see how this is going to fold over and be on there. We can confirm this with some of our points like we talked about earlier. Okay. 1, 2, 3, 4, 5, 6. We got 0, comma 6. So that should flip to 6, comma 0. 1, 2, 3, 4, 5, 6. There it is. Ta-da. What's another nice one that we have? -1, -2, -3, comma 0. And then here we have 0, comma -3. Look at that. Okay, so we can clearly see that they are inverses. Last one here. This is a little bit of a lead-in for tomorrow's lesson with square roots. Okay, we know the steps now. Flip them. X equals y squared, square root. Okay, so our inverse of x squared is going to be plus minus the square root of x. And we traditionally just look at the positive one. And we'll talk about this a little bit. Okay, if you want to write this down with me, feel free. Otherwise, it might just be easier and more beneficial to just kind of follow along. So let's graph our x squared. Okay, 0, 0. 1 squared is 1. 2 squared is 1, 2, 3, 4. And 3 will also fit. 3 squared is 9. So there was 4, 5, 6, 7, 8, 9. We know parabolas are symmetric, so we can flip these over. Okay, also not terrible, right? -1 squared is 1, -2 squared is 4, -3 squared is 9. So there's our parabola. Oh yeah, not bad. It's pretty smooth. Okay, and we talked about the square root of x. Okay, so thinking about our inverses, if I did the 0, what's the square root of 0? 0. Also, our inverse point, 0, 0 would flip to still 0, 0. Square root of 1 is 1. Also, you can look at your point. 1, 1 would flip to 1, 1 still. 2 is not a very nice one. 3 is not a very nice one. Okay? 1, 2, 3, 4. The square root of 4 is 2. Or we could also go by this. 2, 4 is going to flip to 4, 2. Okay, think about where the next nice one's going to be. We had 0, 0, we had 1, then we had 4, 2. Where's the next nice one going to be? 3, 9 would flip to 9, 3, 5, 6, 7, 8, 9, 1, 2, 3. And there is our square root graph. Okay, and you can get the picture here, how it's the reflection of this branch. And I said we usually only do the positive one, because if we did the negative branch down here, we would no longer be a true function, right? Because we wouldn't pass the vertical line test. We would have 2 y values for every x. We wouldn't pass the vertical line test. It wouldn't be a true function. Now what you could do to get around that is you could graph the positive square root of x, and then you could also graph the negative square root of x separately. Okay? If you were looking to do this on your calculator, it's only going to give you the top one, but if you want to see the bottom one with it, you could do these as 2 individual ones, okay? Alright, that was just a little bit of like a sneak peek, little lead in to some square roots. Your work for today is going to primarily be like this. We're working on finding the inverse and then just graphing it so we can kind of see the relationship we have there. Okay? Awesome. Thanks for watching. Best of luck, and let me know if you have any questions.